So, thank you very much. You have almost everything already heard now from John, so I have a little more to add to that. So, I basically going to talk a little bit on what we see, how the evolution of NFV should be, and I'm going to basically give a certain directions and why we do that, and I give two examples. I will not say it's really use case, but it's sort of two examples of stuff we are doing currently or have done at Swisscom to understand what we actually need and to derive certain requirements coming out of that. So that's what I'm going to do. So the first thing is why are we doing that? So today for the residential businesses and residential office, we have sort of the I learned that in this week. It's the T-shirt size model that you have S, M, L, and XL type of contracts with us, and that's mainly driven by what type of service capacity you get. For example, I mean, how much bandwidth you get in the access, how many channels you get on TV, things like that. So that's sort of where we are today, and I compare that with the left side picture. You buy orange juice in different quantity and probably a bit different quality. So that's what's on the left side. Where we really want to go to is that we want to be more of a digital service provider. We want to be more adding different types of services, and that's sort of the picture on the right, which is sort of, you have different types of products in our shop, in a digital shop naturally. So if we want to do that, the question is sort of, what do we need from a technological perspective? So that's where we want to go, and that's why we do a lot of that and why we want to have certain things happening. So I guess many of you have that already seen, but 5G was sort of positioned as a technology for generating new business. We hope that's still true. The initial 5G, that's sort of from a business perspective, that's a sort of a no-brainer. More capacity everybody needs, so that's not a big issue. But the new businesses are coming more in the B2B, B2B2C services, things like reliability, operational services, ICT, stitching together services out of different components, having these new 5G capabilities on IoT, low delay, slicing, and stuff you know. So these are sort of new capabilities available for use in generating certain services end to end. The other thing is more on the NFV side is, I mean, basically since we go cloud technology for network functions, there's no reason to believe why we cannot use cloud technology sort of for everything, which basically allows also third-party applications onto that cloud backends, which then can sort of talk to 5G components. If you have an IoT service, you talk to a certain IoT component from our network through an API or something like that. So that's a way to enable third parties to come on our platform. Naturally need certain API access. It naturally also means there's a mix of network and IT workloads. I'm going to show in one of our examples is an important one. If you need to run SAP plus 5G network functionality on the same cloud. Then we need some sort of cloud-native software architectures. That's for easy deployment and manage the whole thing. Enable scaling, performance management, and reliability. You need end-to-end orchestration, and you need a lot of automation. I think that's nothing new on that. So what does that mean, sort of evolving the NFV for these digital services? I think was already mentioned a little bit, was there are basically two topics. One is that an NFV should be more of a platform. I mean, today it's really like a resource level and resource management thing, what Etsy NFV, Mano, OPNFV and so on is offering. So what we need in addition, we need certain common platform services in the platform which can be used. It's from storage, IoT connectivity, you name it, sort of different types of more added value services in the platform which applications can use that. And the second thing is, from a management perspective, you really want to add these third-party enterprise applications. You need the APIs for accessing that, and today there is no way around having some sort of a cloud-native, Kubernetes, Cloud Foundry type of setup for easy programmability. Programmers don't want to care about all the scaling and management and performance management and so on. That stuff should just go automatic. So that's the first topic. The next one I already heard from John was sort of the moving to the edge. For us, the edge is not completely clear. You can argue that the Swisscom network, which is a very small network, you might regard it as being an edge already. So our whole network could be edge-like. We don't have massive problems with delay. I mean, from our very outside, like everything which is sort of optically connected is something I don't think we are able to generate more than 2 to 3 millisecond delay cross-country. So it's not like the delay issue is not like a big deal there. Still, we want to go into the edge, and there are different things we want to do. And one thing for us, edge can be the central office. In the previous session, there was like Deutsche Telekom talking about the Access 4.0 project they are doing, things like that. We're going to have an example on that as well. Then we have, in another example, we're going to bring is on-premise universal CP or cloud technology. Can be regarded as edge as long as it's sort of managed from our side. And there are a lot of talk about IoT gateways or fog computing or whatever you want to call it. So that can be edge as well. But then there are other things. I mean, your mobile phone these days are like, we see a lot of people using mobile phone just as a gateway to the internet. Like it's sort of like a router. We have cars, buses, trains, you name it. What are sort of edge devices, not end devices, or some sort of edge devices which need to control, need to be managed. You probably want to have a flexibility to load something on there, and so on. So there are different goals for the edge. I just name here 2. It's really like the low delay, which I said for us it's not terribly important because we have a small network, but there is another important thing, is sort of private data and private networks. That's sort of the whole VPN story for B2B and enterprise services. So then the question stays, if you have this edge, is it possible to get a single way of doing all of that? I'm seeing now in the industry several edge computing communities, activities, and so on. And I don't think it's sustainable for the industry to do sort of different things. I would even argue it would be better to have like one single thing. So if you are able to extend NFV or whatever the favorite thing is, to also include many of the edge things through configuration, through certain deployment, I think would be very beneficial. Then there's a question how to model the edge. There's just at the moment, going to talk about it later as well, so there's a discussion in ONAP how you model an edge. That is from like multi-cloud, edge cloud, you model it as a plain physical element or whatever. There are a lot of discussions around that. And then the question is like a monostack, an NFV monostack, is that running edge to edge, or is a monostack really just covering one part? Do I have wrong numbering? No, the edge, exactly. Third one is really the end-to-end service orchestration. Since we talk services, and what we want to provide at the end as an operator is some sort of digital services in whatever form. So you also need to look into end-to-end service orchestration. So the edge we already had, what comes on top if you do service orchestration, at one point you also have physical network functions. It's unfortunately in the operator and networking world, you still have physical elements. For example, things like a cable or some chips in a CPE somewhere at your home. So there is still PNFs around, and sort of all of that sort of should be covered under the same end-to-end service orchestration in one way or another. Now the question naturally, or the challenge is, so like how many domain or how much domain specific these service orchestrations need to be. Many of the people I see talking about service orchestration are then still a bit domain specific. So you might need to have even a sort of a hierarchy of things. What are then the standards and the interfaces to build a certain hierarchy of orchestrators, and how many levels in the hierarchy you have? And naturally, if you have the service orchestrator, I always feel a bit uncomfortable seeing that there is a single point which might fail in one or the other way. So having this controlling entity at top makes me a bit nervous for reliability of the network. So these are sort of three things which we see should change, or where the industry should go. Now I bring two examples. One example, and I apologize if you guys have already seen those examples. We talk about those in other events as well. First example is the Industry 4.0 use case. We have built a proof of concept, not with 5G radio, but with LTE technology. But nevertheless, it's sort of most of it is sort of applicable also in the 5G thing. So the use case is like sort of 4 different cases actually. It's first thing is really real-time data. This industry is building medical devices. Medical devices have a very stringent quality control. So basically, if you do some sort of image recognition and checking the pieces manufactured through imaging and video, you need to have a very quick reaction time to throw away a piece, because otherwise it goes along the production line. So you need to get rid of that very, very quickly, so you have a real-time data thing. Then there is a location of goods. Since you need to do quality control as well as you need to track all the goods, you always want to know which pieces are where in the factory, because it needs to be trackable. If something goes wrong, you can prove that this happened there or it happened there. So there's a location of that. Then there are virtualized production machines. Today, every single production machine has a pretty industrial PC standing at the side, doing a lot of stuff and connected by our Ethernet. So we can sort of virtualize that into a cloud environment, plus we run then radio to that cloud. So we have basically equipped the whole factory with just radio equipment. Basically, the business case is saving cabling and copper. And the last one in the quality control space again is that you have augmented reality to basically check things. You look at parts, and they basically through virtual reality you can see whether it's okay. Plus you use virtual reality to maintain the machines in the factory. So that's sort of the use cases. What does that mean for NFV? Basically, that particular industry we were working with is they basically ask for on-prem IT resources. They're not willing to give out their data to us, so they want to keep the data on-prem on their side. They still want to have off-prem IT resources for bottlenecks and sort of hybrid type of cloud scenarios. They want to have on-prem telco cloud resources. That's basically running the mobile network on their site, sort of a localized mobile network, again, out of security reasons. There's a bit of off-prem telco cloud resources needed as well, because it needs to integrate in the rest of our mobile network. It's still our frequency which is used in that factory. And you have the on-prem 5G radio equipment basically need to be managed. Even in the POC we use just LTE equipment, but doesn't really matter. It's a radio equipment. So that's the physical side. What you see, it's a mix of having stuff on-prem and off-prem. That's what I'm saying. So if the edge is sort of there, then you need to orchestrate across the whole thing. Then there were like slices built up. There was basically a low latency slice within the factory. So that's a very local slice. And that's really for this real-time data things going back and forth. That includes then also some mobile core functionality and on the on-prem cloud. But there is also the normal mobile phone, residential mobile phone or enterprise mobile phone slice of Swisscom being put into the factory, because all these people have their phones there as well. They want to use them normally as well. And there were discussion of having a third one for whatever things. But just you see that even the slice concept can be very local or sort of more global, and you need to bring parts of the slice in here or bring it there and so on. Then the applications, there's basically integration needed with the legacy customer IT. That's They basically run today SAP. They want to run SAP on cloud infrastructure, and SAP tells you exactly on what cloud infrastructure they are able to run, where they give guarantees. So you need to bring that one. It's more the IT workload type of cloud system or virtualized system. And then the new applications, they're really built the cloud way, probably even hosted off-prem, talking to the network services. That's a bit loose, because they're in the POC at least. We have not implemented too many new applications, just build what I've shown you with out of components. So that was the sort of first example. It's a more 5G oriented, more B2B oriented example. The second one is a fixed broadband example, so sort of stepping completely different side. Doesn't matter, because from an end-to-end service orchestration, all of that need to be covered. You see where I'm going. We have a lot of this type of requirements coming in. So here, it's really the fixed broadband thing. Is today in the core domain, it's a no-brainer that you have all types of NFVs. You have a transport network domain. Questions what you do there. And in that particular project, we are actually looking into what's the sort of interface between an end-to-end service orchestrator and the access domain. In that particular case, the broadband access domain. In that project, we use the ONAP open source thing as an end-to-end service orchestrator. ONAP has quite a number of components which are handily available to build up these things. There are also components which are missing, but sort of in general, we just started using that. It's also a bit for us an experiment to figure out whether that piece is good enough or whether it has the requirements we want to have. In that sense, it's an experiment, and it's really an experimental work here. It's part of our labs work. We are doing that. So what happens is we are involved in ONAP in something which is called the Open Source Access Manager, OSAM. And basically what it does is sort of start linking the ONAP service orchestrator, end-to-end service orchestrator, with what is called here the SEBA pod. The SEBA is a sort of a cord-like access network system. Or think of it, you can also have the Access 4.0 from Deutsche Telekom sitting there, or any type of other access network architecture what you want. So that's just showing that we need certain components additionally in ONAP for the access network, and how we model that is a bit of a question. What are the interfaces on it is a bit of a question as well. There was a lot of discussion on subscriber management, where you host the subscribers. Is the access sort of subscriber aware or a subscriber unaware, and things like that. So that's here. And then what we also do is now we also want to model that access, the broadband access service. And that's sort of the upper part in the picture. So the access network service is composed out of different components with different characteristics, different interfaces. And that's sort of at design time, that's sort of what you can design. It's a GUI. You click together this one, and then you deploy it into the infrastructure. It's a one-click deployment. The issue is still on the lower side, on the infrastructure. In that particular case here on the picture, there are certain infrastructure components which are somehow managed from ONAP side, and there are per customer, per subscriber elements in there, which basically need to be sort of configured on demand when customers come, which makes it a bit more difficult. So we have those two sides basically brought into the infrastructure. Okay, so what are the learnings from what we did? So we basically require IT and telco cloud resources. So it's not like a one or the other, it's sort of a mix of these two worlds coming more and more. Because we have still the very different workloads. If you bring a B2B type of services, they have completely different requirements than IO load type of requirements. But we want to run that basically run on the same thing. Otherwise, we need to maintain 2 or 3 stacks. It's not terribly suitable. We require the end-to-end service orchestration. So across different premises, meaning also on-prem at the customer side, up to our central office, our core, and so on. Across physical and virtual network function, and we need to model, design, and deploy the customer service sort of on demand. That's one thing which we sort of try to automate as much as possible. The setups are getting quite quickly complex. If you look at this, it's sort of a very stupid broadband access service. It already starts looking complex, and there's a lot of stuff behind the scenes which you don't see. So it is but operators are used for complex situations. We handle that actually quite normally. We need cloud-native capability and decomposition of concerns to make it manageable at all. And we need a multi-tenant capability also on the end-to-end orchestrator. So it's interesting finding in that Industry 4.0 case that you need multi-tenancy because the customer wants to have a certain access to certain information there and see what's going on in his factory. And with that, I'm done, and thank you very much for your attention.